Hello everyone, good evening. So in the last session, we have seen about your block diagram and reduction of block diagram. So in this session, we are going to see about your questions of this block diagram, and then we are going to study your SFG. And in your next half of the session, we are going to see what? We are going to see your time response analysis. Okay. So let us then begin with today's session. So here you can see for the block diagram, first question of your block diagram reduction. For the block diagram shown in the figure, the transfer function Cs by Rs is equal to. So you need to solve this question. So I am giving you like 1 minute to solve this question. So this is Rs, this is Cs. Okay. So over here we have one more path. Okay. So this diagram and this diagram, both of them are your same. Okay. Same. So basically they have done what? They have replaced this common part by joining this two part. Okay. So now if we want to calculate Cs by Rs, so how are we going to do? So look over here, that input to this block is Rs and output over here is what? It is Rs into 1 by s. So this 1 by s along with this Rs is coming over here. So Rs, okay. Now this will be multiplied over here. So this will be what? 1 by s multiplied with R of s by s plus Rs. Okay. And over here, one more Rs will be added. So I am going to write it. Cs is equal to what? Cs is equal to 1 by s into Rs by s plus Rs plus Rs. Okay, so this Rs, it is also coming over here. So now if you can take Rs common from here and bring it over to the denominator of the left side, so this will be Cs by Rs is equal to 1 by s square plus 1 by s plus 1. So Cs by Rs is equal to what? It is equal to, if you take LCM, so s square 1 plus s square. So option B is your correct answer for this question. Okay. Okay. So the next question we have over here, it is also a very simple question. You can take like 1 minute to solve this question. So you can see over here, they are asking what is ys by xs. Okay. What is ys by xs? So very simple question. You can see at this point, basically your signal is what? Y, sorry, x minus y. I am not writing x of s, y of s in parenthesis. I am just writing x minus y over here. So over here, this will be what? 2x minus y. And this y over here, it is equal to what? Y is equal to, you can see this signal is what? It is 2x minus y. Along with there is one more signal coming over here, so that is x. So plus x. So y is equal to 2x minus 2y plus x. So 3y is equal to 3x, or y by x is equal to 1. Okay, y by x is equal to 1 is the answer for this question. Okay. So the next question we have over here is you need to find once again y by x2s over here. So you can take like 1 minute to solve this question also. So you can see over here it is asked what is y by x2. Y by x2 when x1 is 0. So x1 0 means what is the output over here, or what is the signal present over here? So x1 is 0. So this will be x1 minus y, but x1 is already 0. So this will be what? Only minus y over here. So output over here, this will be what? Minus s by s plus 1 into y. Over here, your output will be what? It will be minus s by s plus 1 y plus x2. So what will be this y? Y is equal to minus s plus 1 y plus x2, and this 1 by s is also over here. So 1 by s. Okay. So now let us try to solve this. So y is equal to minus s by s plus 1 into 1 by s into y plus x2 by s. So ss gets cancelled. So let us transpose this y over to this side. So this will be y common 1 plus 1 by s plus 1 is equal to x2 by s. So this will be equal to what? Y s plus 2 s plus 1 is equal to x2 by s, or y by x2 is equal to what? It is equal to your s plus 1 divided by s plus 2. So option D is your correct answer for this question. You can see over here. Okay. So the next question, it is very simple question. For the negative feedback system shown in the figure, the equivalent transfer function is. So you need to find the equivalent transfer function. So this is one negative feedback system. So for negative feedback system, we know what Cs by Rs is equal to G of S divided by 1 plus GHS. So G of S is given over here. So S plus 3 divided by s plus 2, 1 plus s plus 3, s plus 2, s plus 1, s plus 4. So if we solve this, so you can see that this will be basically what? So s plus 3 means I am multiplying numerator and denominator by s plus 2, s plus 4. So this will be s plus 4 divided by s plus 2, s plus 4 plus s plus 3, s plus 1. So this will be what? You can see this will be s square plus 7s plus 12. Only in one of the option C, you can see the numerator is what? That it is same as the numerator that we are getting. So directly you can mark even without solving this, or you can do one more step. So this will be s cube plus 6s square plus 8s plus s square plus 4s plus 3. So you can see what? That this will be 7s square plus 12s plus 3. So option C is your correct answer for this question. Okay. So with this, we end our block diagram reduction. So very simple questions will be asked. I have even shown you how to theoretically derive any of the block. So you don't need to memorize anything. So if you haven't watched that, watch the previous session. Okay. So in our this session, we are going to see now what? We are going to see your signal flow graph. Okay. So signal flow graph, it is basically a graphical representation of your block diagram. So block diagram, you can see it takes basically a lot of time, and for manipulating the block diagram to get your transfer function, we require a lot of steps. Okay. So it is a kind of a complex procedure to find your transfer function using block diagram. But signal flow graph, it is simple compared to your block diagram reduction. So in signal flow graph, we basically determine the transfer function between two nodes. Okay, two nodes over here. And basically your signal flow graph, it is based on your Mason gain formula. So Mason gain formula, it is actually derived in your mathematics, okay, linear algebra part. And over here, we are using the concepts of Mason gain formula in signal flow graph or in control system. So what is this Mason gain formula? So Mason gain formula, if we want to find transfer function from your input node or source node to your output node, okay, or your sink node. So how do we do that? We have a simple formula. So Ts is equal to summation of all the forward path Pk del k divided by del. Now what is this Pk? So Pk is the kth forward path, kth forward path from input node to source node. Okay, from input node to source node. Del k is what? Del k is your associated path factor of kth forward path. Okay. So what is this associated path factor? So it is basically 1 minus all the loop gain after removing the kth path. Okay, kth forward path. Okay, so del k is what? It is the associated path factor of the kth forward path, and it is obtained from subtracting 1 minus loop gain after removing the kth forward path. Now what is this del? So del is given by determinant. It is known as determinant. So that is 1 minus sum of all individual loop gain plus sum of product of two non-touching loops minus sum of product of three non-touching loops, and so on and so forth. Okay, so on and so forth we have over here. Usually in exam we have up to this point, not more than this it is asked. Okay, so now let us see how to actually derive your signal flow graph from your block diagram. So first stage is to mark all the node position. So remember, your input is one of the node. Your comparators, all the comparators present, they will be taken as nodes. Your takeoff points will be also considered as node, and your output node, means output, it will be also considered as a node over here. So it is termed as your source node also. Sorry, it is also termed as your sink node. So you can see basically, okay, so if I take first, second, third, fourth node over here, so in between 2 and 3 I have a forward path gain, and that is what, g of s. From 3 to 2 I have a feedback path having gain minus h2. Why minus h2? Because h2 in this, and over here we have minus, so that is why minus h2. Now in between 1 and 2 there is nothing marked, so this will be 1. Even between 3 and 4 there is nothing marked, so this will be 1. Okay, so now if I want to calculate your transfer function over here, so that is what, transfer function. First, calculate the forward path over here. So P1 is what? P1, you can see it is from 1 to 2, 2 to 3, and from 3 to 4. And the path gain is what? It is G of S. Loops. So L1, there is one single loop. It is from 2 to 3, and from 3 to 2. So loop gain is what? It is minus G of HS. So this is not H2. Sorry. Now what is this associated path factor? So there is only one forward path. So for that we have del 1. So del 1 we calculate by removing the first forward path, and remember to remove all the nodes in the forward path, first forward path. Okay. So now you can see what, there is no loop present. So this will be what, this will be equal to 1 minus 0, because none of the loops are present over here. So that is why this will be what, this will be your 0. Okay, now what about del? So del is equal to 1 minus individual loop gain, so that is minus gh, plus product of two non-touching loop. There are no two non-touching loops, so this will be 0. So now we have everything in the formula. So transfer function will be equal to P1 del 1 by del, so that is equal to G divided by 1 plus GH, or you can even write G of S divided by 1 plus GHS. So you can see for a negative feedback system we have derived the formula that we know also. Okay, so you can see it over here. So with the help of this Mason gain formula we are able to derive the transfer function in a very simple manner compared to your block diagram. Okay. Okay then. So let us solve few questions. Okay. So now we have what? We have is your limitation of Mason gain formula. So Mason gain formula is not valid for unity gain self loop. Now what is this self loop? Self loop is a loop which starts and terminate at the same node. Okay. So here you can see we have a self loop. So now whenever we have a self loop with unity gain, your Mason gain formula, we cannot actually means derive the transfer function. So look over here. So if you want to write x2, okay, x2. So how can you write it? x2 is equal to a12x1 plus a22x2. You can write it like this. Look over here. So x2 can be written like this. So if you want to write x2 by x1, so then what can we do? So 1 minus a22 x2 is equal to a12x1, or x2 by x1 is equal to a12 divided by 1 minus a22, equation 1. Now let us try to derive x3 by x2. So x3 can be written as a23x2, or x3 by x2 is equal to a23. So let me mark this as equation 2. If we multiply equation 1 and 2, So A12 1 minus A22 into A23 is equal to what? X2 by X1 multiplied with X3 by X2. So X2 gets cancelled. This will be X3 by X1 is equal to A12 A23 divided by 1 minus A22. So this is basically the analytical way of solving for X3 by X1, but we could have simply applied your Mason gain formula also over here. So if we have done that, so let me just shift this over here. Suppose I wanted to calculate X3 by X1 using Mason gain formula. So forward path, if you see, so what is the forward path gain from X1 to X3? That is A12 A23. Okay. Now, what are the loops present over here? So loop, you can see there is only one loop and its loop gain is A22. Okay. Next, what is the associated path factor? So that is 1 minus loop gain. So if you remove this forward path, you can see there is no loops present over here. Okay. No loops present over here. So if no loops are present, so that will be 1 minus 0, 1 minus loop gain. And last is what? Determinant. So determinant will be 1 minus sum of product of individual loops. So that will be A22. Okay. So now if we apply your Mason gain formula, so that will be P1 del 1 by del. So you can see you will be getting the same thing. A12 A23 divided by 1 minus A22. So whichever way you want, you can calculate the transfer function either using analytical approach or you can use your Mason gain formula. You can see that once we have this transfer function, what happens if A22 becomes 1? So if A22 becomes 1, so A22 is what? It is your self loop. Now if your self loop, it becomes 1, so you can see this whole transfer function, it will be undefined because this will become infinite. So that is why in your Mason gain formula, if we have a self loop with unity gain, we immediately remove it for calculating the transfer function because your SFG is invalid for your self loop with unity gain. So remember this, your SFG is invalid for self loop with unity gain. Now next is what? If we have self loop at input. Okay, self loop at input. So that means what? If we have a self loop at your source node. Okay. So now let me write the equation over here. So x11 is equal to a11 x1. Tell me for what value of a11 is this valid? So you might be guessing that when a11 is equal to 1, x1 is equal to x1 and this will be valid. But if a11 is equal to 1, just now we have seen what? That self loop with unity gain is invalid. Okay, so that is why we need to have no self loop at input, because if you consider that for any other value of a11, what will happen? You will have a correct equation over here. So take any other value. Take a11 as 2 minus 2 minus 3, anything that you want to take. So x11, if you take a11 as 2, so this will be 2x1. So x1 gets cancelled. So 1 equal to 2. So this is never possible. So that is why self loop at input is never possible. And whenever we have self loop at input, what we do? We just remove the self loop from the input node or your source node for calculating the SFG. So now over here we have one question. I want you to calculate this. So very quickly do. So you can see over here that we have what? We have one self loop at your input node. So this is R, this is C. So for calculating the transfer function, I need to remove this Y because we have already discussed that self loop at your input, it is not possible. Okay, so we will remove it. So forward path is what? It is equal to G1, G2, forward path gain. Loop present over here is only one, and that is what its gain is minus H2. Okay. Cofactor, associated path factor for this one. So that will be what? If we remove this path along with all the nodes, there will be no loops present. So this will be again 1 minus 0. Okay, 1 minus 0. And delta is what? It is your 1 minus all the sum of individual loop gains. So that is 1 plus H2. So if we apply the formula P1 del 1 by del, so this comes out to be G1 G2 divided by 1 plus H2. So this is the answer, transfer function C by R of this given diagram SFG, okay, signal flow graph. So now we have some questions that we have to solve. So this question is a GATE EC 2003 question. So this is a very good question. Such kind of questions will not be asked in your PSU exam, but this question I have taken specifically to build all the concepts related to SFG. Okay, so let us then solve this question. So in this question, you can see the signal flow graph of a system is shown in the below figure. The transfer function Cs by Rs of the system is. So you need to find what is Cs by Rs. Okay. So let us redraw this. So this is Rs, this is Cs, this is 1, this is 1. Minus 3, minus 4. Okay. So over here you can see that we have this SFG. Now we need to do what? We need to calculate your transfer function Cs by Rs over here. So if you look over here, so the forward path, let us put the node number. So this is 1, this is 2, this is 3, this is 4, this is 5. Okay. So the node forward path will be what? From 1 to 2, 2 to 3, 3 to 4, and from 4 to 5. Okay. So this will be what? This will be path gain is 6 by, sorry. So forward path means from your input node to your output node, or from your source node to sink node. So P1 will be from 1 to 2, and if I mark this node as 6, so from 1 to 2 and 2 to 6. Okay. So your path gain is what? It is equal to 1. Now what about del 1? Or you can see there is one more forward path over here, P2. So P2 will be equal to what? It will be 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3, then to 2, then to 6. Tell me if this path is valid or not. So this path is invalid. Why? Because in forward path, we need to transverse any one of the node just once. Okay. We need to transverse any one of the node just once. So you can see in this path 1 to 2, 2 to 3, 3 to 4, 4 to 5, then from 5 to 3, then to 2. We are transversing this path twice. Okay. 2 and 3, we are transversing it twice. So that is why this is not correct. So this path is not correct. Okay. So now we have what? We have to find your del 1. So before that, let us try to find all the loops. So you can see there is one loop 2 to 3, and again back to 2. So that is what? Minus 2 by s. L2 is what? It is from 3 to 4, 4 to 5, and again to 3. So this is minus 24 by s, and L3 is what? L3 is 4 to 5, 5 to 4. So that we have is minus 3 by s. Now associated path factor. So for that, let us remove this path 1. So if you remove this path along with the nodes, so remember to remove the node also. So now you can see there are two loops. This is one loop and another is 3, 4, 5, 3. So that will be 1 minus all the individual loop gain. So that will be what? Minus 24 by s and minus 3 by s. So this is 1 plus 27 by s. So now what will be determinant? So determinant will be 1 minus sum of all the individual loop gain. So that will be 27, 29 plus product of two non-touching loops. So you can see this two loop. Okay, so this 2, 3, 2 and 4, 5, 4, it is basically what? It is your non-touching loop. So that will be 6 by s square. So now we can put it in the formula. So that will be what? 1 plus 27 by s. P1 is 1. Del 1 is 1 plus 27 by s divided by 1 plus 29s plus 6s square. So let us multiply in the numerator and denominator by s. So this will be s plus 27 divided by s square plus 29s plus 1. Sorry, plus 6. So which option do we see? Option D is your correct answer for this question. Okay. So in the next question, it has been asked in the signal flow graph. Sorry. In the signal flow graph of the figure, the gain C by R will be. So you need to find what will be the C by R of this figure. So you can see over here that if you want to find C by R, so first let us draw this. Okay. So let us mark the node also 1, 2, 3, 4, 5 and 6. Okay. So these are the nodes that we have over here. So now if you want to calculate the forward path over here, so P1 is equal to what? It is from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. And what is the path gain? So that is 1, 2, 6, 24. And P2 is what? From 1 to 2, 2 to 5, 5 to 6. And path gain is what? It is equal to 5. Okay, path gain is 5. So now what are the loops present over here? So L1 over here is 2 to 3 and 2 2. So 2 3 2. Loop gain is minus 2. L2 is 3 4 3 and loop gain is minus 3. L3 is 4 5 4 and loop gain is minus 4. One more loop you can see, that is L4, that is 2 2 2 5 4 3 2. So 2 then to 5 then to 4 3 2. Okay, so what is the loop gain? This is 5 and there are 3 times minus 1, so this will be minus 5. Okay, so now let us try to find the associated path factor del 1. So del 1, you can see over here that if we remove this first path, there will be no loops remaining. Okay, there will be no loop. So this will be 1 minus loop gain. So 1 minus 0 because there are no loops present. So 1 minus 0. Del 2 is if we remove this path. Okay, if we remove this path. So now you can see if we remove this path, there will be only one loop, that is 3 to 4, 4 to 3. Okay, so that is what? L2. So 1 minus L2. So that is 4. Now let us calculate delta or determinant. So that will be 1 minus individual loop gain. So minus 5 minus 9 minus 5. So that will be minus 14 plus sum of product of two non-touching loops. So this loop and this loop is non-touching. So that will be plus 8. So we have over here is what? 22, 23. Okay, so now let us put, so P1 del 1. So that is 24 plus P2 del 2. So 5, 4, 20 divided by 23. So that is 44 by 23. So option D is your correct answer for this question. Okay. So the next question over here we have is what? The signal flow graph representation of a control system is shown below. The transfer function Ys by Rs is computed as. So you need to find what is Ys by Rs over here. Okay. So very simple question. Okay. So now if you check over here, so you can see 1, 2, 3, 4, 5, 6 we have. Okay. So if we want to calculate the forward path, so forward path P1 is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and the forward path gain is 1 by S cube. Another forward path we have from 1 to 2, 2 to 5, then to 6. So that is what? 1 by S. Now what are the loops over here? So L1 is 2 to 3, 3 to 4, and again from 4 to 2. So that is minus 1 by S square. L2 is from 3 to 4, 4 to 5, then again to 3. And we have one more loop over here. If you see carefully, start from 3, 3 to 4, 4 to 2, 2 to 5, then again to 3. So that is path gain is what? So 3 to 4, 4 to 2, then to 5, then again to 3. So path gain is 1 by S minus 1 by S minus 1 by S square and minus S. So that will be plus 1 by S square. So now if we remove the first path, there will be no loop. Even if we remove the second path, there will be no loop remaining. So that is why del 1 is equal to 1 and even del 2 is equal to 1. So this will be P1 del 1. So 1 by S cube dot 1 plus 1 by S squared dot 1 divided by 1 plus, if we have to calculate delta, so that will be 1 plus all the loop gain. So loop gain over here will be 1 by S square because 1 1 will be getting cancelled, minus 1 by S square plus 1 by S square. So only 1 by S square will remain. So if you take 1 by S square common from here, so that will be, sorry, 1 by S should have been taken common from here because this is 1 by S. So this will be 1 plus 1 by S square divided by 1 plus 1 by S square. So if you cancel this two, you are getting 1 by S as your answer. So option A is your correct answer for this question. Okay, so very simple question. So in HAL exam, these all kind of questions will be asked in your from SFG and block diagram. So we have seen, even the theoretical part we have seen. So in this session, we have completed your SFG and block diagram also. So in the next session, we are going to see all about your time response. Okay. So in the next session, we are going to complete this time response chapter along with your questions. Okay. So in the next session, we will see this. Okay, then see you in the next session. Thank you.